Hello class, let's continue with the resolution of these problems, the ones from the survey, the ones that you identified as the most difficult. There was one on section 2E. Let me go very briefly over there. The one about interest rate. This one, number 3. Don't worry about this one, guys. Don't worry about this one. It's not going to be in the exam. You don't have to do it. I'm not going to explain it. And the reason is that I want to talk about interest rate when we study the exponential and the logarithmic function. At the moment, I don't think it's necessary to do this problem. If you already did it, which is not that difficult, okay? It's really not that difficult with a little investigation. If you already did it, perfect. If you haven't done this one, don't worry. You don't have to include it in the exercises, and it's not gonna be in the exam. So don't worry about this problem. Now let's jump into section 2F. In section 2F, you told me to address problems 1, 2, and 5. So let's do that. Like I said before, I'm not gonna be going through every single thing, right? I'm just gonna basically give you an outline of how this problem is done, maybe resolve some of these letters, and that's about it. I'm not gonna be doing every single thing for you. Okay, given the functions f, g, and h, find all of these things. 1, 2, 1, 2, 3, 4, 5, 6, 7. 7 little questions or exercises, and then letter B. Okay, so basically, guys, if you notice here, it's all about composition of functions, right? And we know how to do this by now. You should know. Let me do, I'm pretty sure you can do this one right here. This one is also perfectly okay, like having a composition of function with itself, that is perfectly okay. If you want to do this one, f of x, or f composed with f, then what you have to do is this, like basically, I'm sorry. Well, no, let me write down. If f of x is equal to minus x squared plus 5x, and if you want to calculate f in this value, in f of x, then all you have to do is introduce f of x in here, right? And what is f of x? F of x is all of this thing. So basically, you want to evaluate f in this number, in minus x squared plus 5x. And that's going to be equal to minus x instead of x. You should place all of this thing plus 5x. That's it. That's it. I'm done. This is technically f of x. Do you need to raise this binomial to the square? No, you don't. You don't need to. This is already perfect. F of h of x, it's pretty much the same. Remember this notation, guys. What does this mean? When you have it like this with the circle, g composed with f, it means exactly the following. Okay, so if you know how to do this, then you know how to do this, because they mean the same, right? F composed with f composed with f of minus 1. So that is f of f of f of minus 1. So basically, you first have to find this one, f of minus 1. How much is f of minus 1? Well, let's see, f of minus 1, if you take a look at this, that's going to be minus 1 to the square plus 5 times minus 1, and that is going to be minus 1 minus 5, that's going to be minus 6, right? And so you can simplify all of this into f of minus 6, right? And you keep doing the same process. Now you have to calculate this, f of minus 6. Same idea. You know f of x, which is equal to this, and now you just have to evaluate in this number, in minus 6, right? So it's going to be minus 6 to the square plus 5 times minus 6. How much is this? This is gonna be minus 36 minus 30, so it's gonna be minus 66, and all of this thing boils down to f of minus 66, and then you finally do this evaluation and you're done. Okay, so that's pretty much the whole thing, guys. It's not that difficult. All of this thing is not difficult. Maybe the only difficult part is this. This could be a little difficult. So let me tell you how that's done. State the domain of parts. All of these domains. Let's do this one, and that's it. So f of g of x, you have this f of g of x. So the domain. What is the domain of this thing? How do I know? How do I even know the domain of this function? Okay, the first thing you gotta understand, guys, is that you have to work with the domain of g of x, because you're gonna be evaluating this function first, right? You're gonna be evaluating this function first, and then you're gonna be evaluating f in the output of this thing. What is the domain of g? It's all the real numbers. The domain of g is all the real numbers, right? So you're gonna be putting uh, real numbers in here, and it's gonna be basically, how can I tell you this? When you give any value in here, g will be able to calculate it, right? For any value x, g will have no problem, right? Okay, and then next is f. What is the domain of f? That's also the real numbers, right? So in this case, we have no problems. The domain of f composed with g is the real numbers, okay? Because neither the inside function nor the outside function have any problem with any particular number that can cause divisions by zero or negative roots or something like that. But in here, you're gonna find something quite peculiar. That's why I highlighted this one. What's gonna happen here, guys? We have g composed with h of x, which is the same as this g of h of x, right? Like so. And this is a little trickier. Okay, why? Because you can understand first this. What is the domain of h? Let's calculate the domain of h independently of g. Let's calculate these two domains independently. The domain of h is from 0 to infinity, right? Because I cannot, since h of x is equal to the square root of x, I cannot give any negative value. That's why this is the domain of h. The domain of g, though, is all the real numbers, no problem in here. Okay, so basically, what's gonna happen, guys? The following is gonna happen. Take a look at this function first, h of x. That's the function that you're gonna be evaluating first. All right. So from the start, the only numbers that we can give to x in here are these types of numbers. Okay, from 0 to infinity, 0 including, right? And that's gonna be, in the end, that's gonna be the domain of this function. Okay, of g composed with f. It's gonna be this one, because this has no g has no restrictions. You can give any value to g. Okay, but h does have restrictions. So basically, the domain of g composed with f is going to be this one, which is much more restricted, like this. All right. Should I do another one? This one is, no, f of g. No, that's the only problem, actually. These are the only two interesting ones. For the rest, you can do pretty much the same for the rest. Okay, let me do this one. Number three. So f of h of x, same idea. What is the domain of h? The domain is this one that I told you here. What is the domain of f? The domain of f is all the real numbers. So basically, you cannot give any value you want to x in here, okay? You cannot. You first have to attend to the domain of h, which is the one that has a restriction, right? So the domain of this composite function composed with h, f composed with h, is going to be the same as h, because that's the one that is restricted, or restrictive rather. Okay, it's going to be this one. Yeah, it's pretty much, that's the whole thing. That's how it works. So let me stop it right there. Problem 1 is done. Let me make a pause and then I'm going to come back. Next, from that same section, section F, you asked me about the problem number 2. You know what? I already solved this one, but I think I only posted it in a certain group. But I mean, basically, since I don't want to waste time doing it, or once again in here, I'm gonna give it to you as a bonus later. I'm gonna make the post, but this one I have already solved it, so that's it, right? Now let's jump to problem number 5, which is this one right here. Okay, let me make a pause so I can read it completely. No, class, don't do this either. This is confusing. I don't know what could possibly these composite functions mean in this regard. I mean, I already read it several times, and I don't know. I just don't get it, to be honest with you. I don't know what this could mean. Don't do it. Don't do this one either. Okay, you can bypass it. This one is weird. Okay, so that solves exercise 2F. So let's go to section G. So from section G, you asked me about problem 3 and problem 4. Section G to G. Problem 3, using the graph below, find all of these things. This is quite simple. So for example, find G of f of 0. So what you have to do, guys, is this. First, you have to find f of 0, right? And they tell you here in the graph that this, I think this is red or pink, and this is green, right? I told you that I'm a little daltonic, so I don't know. I'm gonna call this pink and this green. So F is pink, G is green. So how do you find, by using this graph, how do you find f of 0? Well, just focus on the pink graph. Imagine that this green one is not even here. So the value of f of 0 is basically having this as an input, or basically the x, right? When the x is 0, you can see that the point corresponding to that value is also 0. So f of 0 is 0, right? And that's it. That's the first part. Now I have to evaluate g in that particular value of 0. So g of 0. I now pay attention to the green one, and g of 0, that's when x is 0, which is this value. The output is -4. As you can see, it's this point right here. That point is 0 comma -4. This point belongs to the green graph, and that's the point for which you have an input of 0 and an output of -4. Therefore, g of 0 is -4, and that is your final answer. This is -4. G of f of 1, same idea, right? First calculate f of 1. This is 1. That's the input that we're giving to f. And what output is giving me? It's giving me the output 1, as you can see, right? So f of 1 is equal to 1, according to the graph. And now we need to evaluate g in that value, right? G of 1. Okay, so I come to the green graph. I go like 1, and then I try to find the corresponding output, which is -3. It's this point right here. Sorry, 1 comma -3. So that's it. G of 1 is -3, and that's the value that should be here. So that's how it's done, guys. Pretty simple. And the same for this and the same for this. Okay, finally from section G, the problem number 4, this one, create two functions f and g, each a set of ordered pairs such that f of g of -1 equals 2. That is the requirement, guys. They're giving me a requirement. They're telling me, you know, you can create any function f as a set of ordered pairs. I need to put ordered pairs in here. How many? They don't tell me. I'm completely free. With what type of relationship between the input and output, they don't tell me. I'm completely free to create whatever f and whatever g I want, as long as I respect this requirement. F of g of -1 should be equal to 2. Okay. How should you interpret this requirement, guys? Basically, when you give -1 as an input to g, right? Then G is going to give you some output, and that output is actually all of this number. Okay, so basically, let's draw G and let's draw F, right? So when I input -1 to G, G is going to give me G of -1, which is this thing inside. And then when I give this value to F, okay, F has to give me 2 in return. Okay, you see? So basically, I can do something like this, and look, I can do something like this. I can create right from the start. Let's not lose any time. Let's give an ordered pair to G. Let's give it -1 because that needs to be the input, and I'm completely free to choose this other value, guys. The output should be 3. Okay, -1, comma 3. And then when I give this particular value, guys, 3, which is G of -1, right? You have to understand that. What this pair means is that when you give -1 to G, it gives you 3 in return, which is this value right here. It's G of -1. That's going to be 3. And therefore, when I give 3 to F, F has to give me 2 in return. So that's it. Just do that. Just write 3 and then 2. And basically, guys, you're done. You can create any other thing like 1,3. This is completely random. Like I'm making things up, and it's okay. 4,9. And here I can create 2,0 and 3,8. That's it. Yeah. My function is 3 ordered pairs. This other function is 3 ordered pairs. And these two things fulfill this requirement. Okay, and if you want me to prove it, here it goes. How much is just pay attention to this, guys. How much is G of -1? In other words, when I give -1 as an input to G, what is the output that G is giving me? It's giving me 3. Okay, so G of -1 is 3. All right. Now, if I consider now F, and if I give F the value of 3, which is this, G -1, how much is F giving me in return? It's giving me 2. Okay, so that's it. I have actually complied with this thing, right? If 3 is equal to G of -1, then I can change this for F of G of -1, and that's equal to 2. And this is actually the requirement that they asked me in the first place. F of G of -1 should be 2. So there it is. Okay, guys, you need to understand this. In this type of problems, there are more ways that this can work, I guess, than ways that it can't. Like it's very easy to think up something like this. You have many possibilities. You can create these things on your own. Okay, it's actually quite simple. Okay, so that finishes uh, section G. Now we have H, I, and J, and the chapter review. I'm gonna cut this video right here. I'm gonna stop it, and I'm gonna continue with another one in a moment.